Have you ever wondered why Jupiter, the largest planet in our solar system, is often referred to as a failed star? Let's set the stage. Jupiter, a behemoth in our cosmic backyard, is a gas giant planet, dwarfing its planetary siblings in size. Its colossal dimensions and gaseous nature have led some to liken it to a star. But why a failed star? Now that's where things get interesting. Stay tuned as we delve into the fascinating reasons behind why scientists often call Jupiter a failed star. To understand why Jupiter is considered a failed star, first, we need to comprehend what differentiates a star from a planet. Let's start with the stars. Stars are celestial bodies composed mostly of hydrogen and helium, with a sprinkle of other elements. They're not just glowing orbs in the night sky, they're powerhouses, generating immense amounts of energy. The magic happens deep within their cores, where temperatures and pressures are extreme. Here, hydrogen atoms are squeezed together in a process known as nuclear fusion, creating helium and releasing energy in the process. This energy travels outward, eventually radiating into space as heat and light. This is what makes a star shine. Planets, on the other hand, are completely different. They're not self-luminous, but rather reflect the light from their parent star. They're made up of a wide range of elements, not just hydrogen and helium, and can be rocky, gaseous, or a mix of both. The most crucial difference is that planets do not have the necessary conditions for nuclear fusion to occur in their cores. Instead of generating their own light and heat, they rely on their parent star for energy. Now let's talk about Jupiter, the largest planet in our solar system. Jupiter, like other planets, does not have nuclear fusion occurring in its core. It's composed mostly of hydrogen and helium, much like a star, but it's not massive enough to generate the extreme pressures and temperatures required for nuclear fusion. Instead, it reflects the sunlight, just like other planets, and emits heat left over from its formation and due to gravitational compression. So while Jupiter shares some characteristics with stars, such as its composition, it lacks the key feature that makes a star, the ability to sustain nuclear fusion in its core. Without this, Jupiter remains in the realm of planets, not stars. So, if Jupiter doesn't undergo nuclear fusion like a star, why do we call it a failed star? Let's explore this mystery. Despite being a planet, Jupiter possesses certain characteristics that are typically associated with stars. As we delve deeper into these characteristics, you'll find that Jupiter is no ordinary planet. It's an exceptional celestial body that shares some remarkable similarities with stars, blurring the lines between planet and star in some very intriguing ways. Firstly, let's consider Jupiter's sheer size. Jupiter is the biggest planet in our solar system, more than 11 times the diameter of Earth, and it's this immense size that gives it a star-like quality. If it were 80 times more massive, it would be capable of initiating nuclear fusion in its core, just like a star. But as it stands, Jupiter falls short. Now let's talk about what Jupiter is made of. Like the Sun, Jupiter primarily consists of hydrogen and helium. These elements, particularly hydrogen, are the building blocks of stars, fueling their nuclear fusion processes and enabling them to shine. Jupiter's composition is so similar to that of the Sun that it's often referred to as a gas giant. Finally, Jupiter's strong gravitational pull also gives it a star-like quality. This gravitational force is so powerful that it's capable of holding more than 60 moons in its orbit, a characteristic more commonly associated with stars than planets. This gravitational pull is also responsible for Jupiter's intense atmospheric pressure, another star-like feature. So we see that Jupiter, in all its grandeur, shares some striking similarities with stars. Its massive size, its composition of hydrogen and helium, its strong gravitational pull, all these features point towards a celestial object that could have been a star under different circumstances. But as it is, Jupiter remains a planet, albeit a very special one. So, Jupiter has some star-like qualities, but it's still a planet. Why then do we refer to it as a failed star? The term failed star is a bit of a misnomer. Jupiter didn't fail at becoming a star. It simply didn't have enough mass to succeed. It's like calling someone who decided not to run a marathon a failed runner. It's not the right term, is it? Now, let's get into the nitty-gritty of star formation and the role of mass. Stars aren't born out of nothingness. They originate from massive clouds of gas and dust, collapsing under their own gravitational pull. This process generates intense heat and pressure in the core of these fledgling stars, eventually triggering nuclear fusion. This is where the magic happens, folks. Hydrogen atoms start to combine to form helium, releasing an enormous amount of energy in the process. It's this energy that lights up the star, and voila, a new star is born. So how does Jupiter fit into this picture? Well, despite being the largest planet in our solar system, Jupiter is still a small fry in the cosmic scale of things. To ignite nuclear fusion and truly become a star, Jupiter would need to be approximately 80 times more massive than it currently is. That's a whole lot of extra mass. Jupiter, despite its impressive size and star-like qualities, simply didn't have the mass to make the cut as a star. So while it may not have made it to the stellar big leagues, it's still a fascinating and important part of our celestial neighborhood. Let's summarize what we have learned about Jupiter, the so-called failed star. We've delved into the fascinating differences between stars and planets. Stars, like our Sun, ignite through nuclear fusion, a process requiring a tremendous amount of mass. Planets, on the other hand, don't have the necessary mass to trigger this fiery transformation. Jupiter, despite being the largest planet in our solar system, simply lacks the mass to become a star. However, it does exhibit some star-like qualities, such as its strong magnetic field and the composition of its atmosphere, which is predominantly hydrogen and helium, much like a star. But let's not get tangled in the semantics. Jupiter may not have become a star, but it's far from a failure. Its immense size, captivating bands of clouds, and intriguing moons make it a standout character in our celestial neighborhood. So there you have it. Jupiter isn't a failed star, it's a successful planet. It's the largest in our solar system and continues to fascinate scientists and space enthusiasts alike.